Alright, hello everyone. So today we're going to be learning about files and how to interact with them in Python. So normally, whenever you do something in a program, everything you do is stored in memory. So if I had something like my number equals 5, this value would be stored in memory, and once my program stops running, it will be destroyed. I will never be able to get this value back until I rerun the program. But that's actually a real problem if I want to have some kind of persistent storage. So what that means is I want the data that my program somehow gets or creates to be stored for longer than the lifetime of the program itself. Right? So this is where I stored in files. So if I can somehow write to a file, then even after the program stops, the data that the program put in that file will still exist. Right? So what we're going to look at in this video only is how to open files, how to close files, and why you actually need to do these in the first place. Then later we're going to look at reading and writing to files like you normally would to store data. Alright, so let's get into opening. So here we create a variable called file handle, and we set that to whatever this open function returns. So this open function takes 3 arguments, but we're only going to go over 2 for now, which should suffice. So the first argument is the file name. So here, I have a file called hi.txt. So we're actually going to change that to open hi.txt to match this file. And then we're going to supply a mode. So these are the modes you really only need to care about. We have reading, writing, reading and writing, appending, and reading and appending. So what you do is if you want to read a file, you put R here. If you want to read and write, you can either put R plus or W plus. If you only want to write, you can just put a W. If you only want to append stuff to the file, so add things on to the end of it, then you can just put A. And if you want to read and append to files, then you can put A plus. So what this does is it creates a new handle that you then store in this variable. So now you can do whatever you want with this handle. You can write to it, you can read from it, and it'll do the appropriate actions on the file that you specified right here. So now in order to close this file, we just do file handle.close. Alright, so what this close function does is when you open a file, it creates something in memory. We're going to go over what it is later, but it creates something. So once you're done doing whatever you need to do with this file, right? So let's say you wrote a couple things, you read a couple things, but now you're done with that file. You don't want to interact with it anymore. What you do is you call the close function, and this close function will remove this handle from memory. So it will basically free up the memory that this took up. And so now, if I were to access file handle down here, so like if I wanted to write to the file, I can't, because then I have to open it again, since I closed it up here. Alright, so now we're going to take a look at why we actually used that open function in the first place. Because you might be thinking, why can't we just, supply the file name every time we want to read and write? Why do we have to go through the trouble of using the open function and the close function? So hopefully this will clear things up. So here we have an outline of just an example file structure I made up. Right. So here we have the root directory, which is represented by a slash, and then inside of this root directory we have a folder called downloads and documents. Inside of our documents folder we have a file called 1.txt and another file called 2.txt. So again, this is just a completely random file system structure I made up. So you're probably going to have like a C drive and then users, your username, then documents, then all your documents. And so these nodes right here, they represent either a file or a directory, right? So really, this is just a giant tree. So let's say I want to find /documents/1.txt, right? So this node right here. Well, I would start at the top of the tree. So that would be this node right here. Then I would go into this folder downloads, I would see there's nothing there. I would go back up. I would go into documents. I would see there are two files, 1.txt and 2.txt. Then I would search each file for the file name I want. So I would go to 1.txt and see, hey, this is the file I want, right? So then I grab this node and then I store it somewhere. Okay, well, why do we need to do that? So these nodes actually contain different information about the file, right? So you have stuff like the file name, the permissions that you're allowed to use. So like whether you're allowed to read or write the file, or if you're allowed to run the file. They also contain the last time the file was read from. Then they also contain the last modification time, the last creation time, and so on and so forth. So these nodes actually contain a lot of useful information, right? Oh, and the file size, I forgot about that. So what we want to do, instead of traversing this giant tree, and obviously this tree will get larger as you get more files, instead of traversing this entire tree every time we want to read a file or open a file, write to a file, we instead grab this node, right? And we store it somewhere. So when we want to read from a file, we already know all the information we need about this file without having to traverse this tree every single time we want to read or write to it. So what normally happens is when you call open, this program finds the file you want in this tree, right? It retrieves the node and adds it to an array of open files, right? So these are all nodes and this is an array. And so what happens then is you have a bunch of open files and you have variables assigned to them. So like file handle 1, file handle 2, file handle 3, right? And so every time you access a file handle, like that variable, you want to read from a file or write to a file, you access a variable. And so that variable matches with one of these nodes in this array, right? So you don't have to traverse this tree again. You can just look in this array of files that are already open, and then you can perform the operations you want on this file. Now, this takes memory, right? So when you add a node to this array, it'll take memory, and more memory. So what you want to do when you're done modifying a file, you want to close it. So what closing does is it removes them from this array, and so therefore it frees up memory. So when you're done with the file, you just free up the memory that you don't need anymore, and you'll be fine.